Hello. Today we will talk about the heavy oil thermal recovery engineer. The first part is heavy oil half and half recovery. This lesson we will talk four parts. The first one is principle of thermal half and half. And the second one is production performance of the thermal half and half. And the third part is effect factors of half and half. And the fourth one is the measure of enhance of the effect of thermal half and half. Let's begin at the first part, principle of thermal half and half. Before we talk about the principle, we will have a question. How high the temperature of reservoir steam stimulation will be? Okay. 1.1 Basic conception. Definition. It is called half and half thermal recovery or cyclic steam simulation that some amounts of steam with certain temperature and pressure are injected into the reservoir, soak for several days, and then recover the heavy oil. The main parameters for half and half thermal recovery. There are some parameters. The first one is steam injection intensity, 80 to 120 pounds, or this is for the vertical well, and 10 to 14. This is for the horizontal well, and the injection time is 3 to 20 days, and the steam quantity downhole need to above the 50%, and the injection pressure need lower than the breakdown pressure, and soaking time is 2 or 7 days, stimulation cycles 5 or 7 cycles, or sometimes maybe about to 10, and the oil recovery rate 3 to 8%. The 1.2 is stimulation mechanism. The first one is greatly reducing the viscosity of heavy oil. The second one is fully takes advantage of elastic energy of the reservoir, and might have the effect of SAGD as well, where the reservoir is sink, and have the effect of supplement energy function from cold oil to the heating zone, and have the effect of compacting formation, and then have the effect of steam flooding, and have the effect of thermal cracking heavy crude oil. The mobile oil will increase because of the increasing effective permeability, and might have driving oil effect from frigid water. The 1.3 is Steam Stimulation Technical Evaluation Index. The first one is Serling production rate and total stage production rate. And the second one is Salic oil steam ratio and the whole half and half stage oil steam, and the oil recovery rate, and the circle water recovery rate, and total stage production rate, and crude production cost, and half and half stage oil recovery rate ratio, and production time, utilization rate and utilization rate of oil wells, and steam stimulation stage of reservoir pressure decline. Okay, let's begin at the part 2. Prediction production performance of the thermal half and half. 2.1 Introduction. In order to better understand some basic conceptions of steam stimulation process, it is necessary for us to do a manual conclusion on prediction production performance of steam stimulation well. Although normally it is done by the three-phase or three-dimensional numerical simulation software. The calculation method is called Borberg and Lanz, and assimilation is homogeneous reservoir, radial steam injection, multiple layer formation with the same injection radius. Calculation steps. The first one is calculation variable heat loss, and the second one is calculation the heating area of the formation around the wall, and the calculation the average temperature with the heated area. Calculation crude oil viscosity within heating area and calculation the oil production rate. Calculating the heating area of formation around a well, and repeat the step of the previous calculation for the later circles. 2.2 is the calculation of heated area. Hypothesis. We suppose that there only exists steam within heating area, so there would be no hot water zone. Therefore, the temperature of reservoir within heating area is corresponding saturated temperature. The hot water temperature decreases steeply to the original reservoir temperature, and the formula of heating area is here. In the formula, the AT it means heated area, and the HO it means average heat injection rate, and lambda OB is the overburden layer heated condition affecting, and the D is the overburden thermal diffusing coefficient, and the H is the Poisson thickness, and the average heated injection rate is HO. The formula is here, and the MS is steam injection rate, and XG is bottom hole steam quantity, and HFG means latent heat of evaporation, and HFS is surface of the raw water, and the HFR means water insurface at the reservoir temperature. The dimensionless time is Td. TD is formulated here, the 3-1. The lambda OB is the whole of the overburden layer heated condition coefficient. The M is reservoir volume heat capacity, and the D is the overburden layer thermal diffusion coefficient, and the T is steam injection time. Delta T is Ts minus TO. Ts is steam temperature, and TO is initial P zone temperature. The reservoir volume heated capacity with water. The formulated here. The average reservoir temperature within the heated P zone area at the end time of soaking process. Formulated here. The Ts means saturated steam temperature, and the Tr is the initial P zone temperature, and the Vr is the reduced direction heated transfer coefficient within heated area, and the Vz is the vertical direction heated transfer coefficient within heated area. 2.4 is the average of reservoir temperature at the starting production time. Ts, it means saturated temperature. Tr means reservoir temperature. Vr, reduced direction heated transfer coefficient within heated area. Vz, vertical direction heated transfer coefficient within heated area. Lambda is the coefficient of carried heat by production fluid. For Vr has a formulate, and for Vz has a formulate too. Here, the lambda means reservoir thermal diffusivity coefficient, and RH is the radius of heated area of reservoir, and HL means the formation thickness added. The coefficient of the carried heat by the produced fluid. The formulate is 7-1. HF, the carried heated by produced fluid, and Tg, steam injection time. H means P zone thickness, and T means starting production time. The carried heated by the produced fluid is formulated is like this, where the QOH means oil production rate, and the PO means oil density, and the CO means oil specific heat, and CG means natural gas specific heat, and HWS and HWR means produced water inverse individual at temperature, and LV means the water latent heat at temperature, and the RW means production ratio of water to oil, and RWV means the ratio of steam to oil. If the bottom hole water temperature higher than the saturated temperature, it means PW above PWV, the water is produced in the state of the steam. Then the formula of RWV has a sharp lag. Sharp lag the following equation just like this. The Rg means the ratio of gas to oil, and Pw means bottom hole pressure of production well, and Pwv means water saturated pressure at the average temperature. 2.6 oil production rate during half and puff. If we want to predict the oil production rate during thermal production period, firstly we should know the cold production index and the present reservoir pressure. This is the formula for this QOH. QOH means steam half and puff production rate. The G means the index ratio of the cold production to thermal production. And GH means the production index of thermal production. And GC means the cold production index. Delta P means production drawdown pressure. PW means production bottom hole flowing pressure. And UOH means individual oil viscosity of the cold production and thermal production period. And C1, C2 means geometry factor. See the following table. Uh, 2.7. The residual heat at the end of the thermal production period. In order to predict the next cycle production performance of the thermal well, we should calculate the residual heat of the last cycle stimulation. The formula 9 is this. When we predict the next cycle production performance, we should add the residual heat into the amount of the heat. Ah, 2.8. Case for the thermal production well production performance. This is a software to calculate the temperature of the steam, and you can see the red one. Average temperature at the soaking time end is 248 and the average temperature at the circulating time is this 96.6. This one, how can we calculate? We use the formula we talked before and make the software, and we input some parameters, and then we can calculate our need. Okay, let's start at the third part, effect factors of thermal half and puff. At first, we will have a question. What are the main effect factors of steam stimulation? One, the higher the quality of steam is, the better the steam stimulation effect is. We can see in the picture. The stimulation parameters is piezo thickness is 6.8 meters, and the permeability is 1.07, and the saturation is 64%, and the reservoir temperature is 69, and the injection rate is 7. This parameter is the same. And we change the steam quantity. We say when the steam quantity is higher, the production rate is higher in the before period of the one cycle. So we need to make the steam quantity higher, and we can get the good production rate. Uh, 3.2. The effect of the total amount of injection. The stimulation parameters is the same. Thickness is 68, and the permeability is 1.07, and the saturation is 64%, and the initial piezo temperature is 65, and the injection rate is 8. We can see the picture. The total injection amount is the more total injection amount, and they can get the good production rate in the first period of the one cycle. So conclusion is the injection amount can't be too small, or otherwise the peak production rate will be too low, and provided the amount is too high, the total production amount of steam stimulation cycle mustn't be high. Uh, 3.3. The effect of injection rate. We can see the picture. The piezo thickness is 10 meter, and the injection rate is 1.05, and is 105 and 75. We can say the injection rate itself has no particular effect to the production rate. However, the high injection rate can make downhole shorten. Can make the downtime shorten. The lower the steam injection rate is, the higher the steam heat losses is. Thus, that it will decrease the effect of the half and puff production. Generally, injection rate should be as high as possible, but it should be controlled within the range where the formation cannot create steam breakthrough along the fracture of formation. It will be badly influenced to the production. Generally, injection rate cannot be lower than 4 ton per hours. For example, in our field, C oil field, the horizontal where the injection rate is 17 ton per hour, and the vertical where is 5 ton per hour. Uh, 3.4. The effect of the stimulation pressure. The first picture shows the effect of the injection pressure to the production rate. Production pressure drop is 10 to 3.5 equals 6.5 ampere, and the injection pressure is 15.2 ampere. And the second line is production pressure drop is same as the one, 6.5 ampere, and the injection pressure is 13.1 ampere. We can see the injection pressure is higher, the injection pressure higher, and the production rate is good. The second picture we can see the pressure drop is 65 ampere, and the injection pressure is the same as the first one. And the second line is the pressure drop is 4.5 ampere, is some less than the one, and the injection pressure is 13.1 ampere. We can see the first one is much better than the second. So the stimulation pressure itself has little effect to the production rate, but under the same production pressure difference, the injection pressure has little effect to the total production rate. It's better that production operation performs under the low stimulation pressure with the proper injection rate. The steam injection pressure cannot be higher than the breakdown pressure of the reservoir in order to avoid the steam channeling. Effect of soaking time to the production rate. The picture shows us the effect of soaking time to the bottom hole pressure. We can see the soaking time of Kaohsiung oil field. This oil field is in China. Petro China is about 5 days, and the design of emerald oil field, C oil field, for horizontal wear is 6 to 7 days, and for vertical wear is 5 days. How many days for the soaking time should be decided according to the real condition of the oil field and how much the steam inject. Strictly speaking, in order to decide the soaking time, should make wear test for getting the downhole temperature. Three point six is optimization design of steam injection process. The first one is the order of influence of parameters on thermal recovery effect, steam injection dryness, above, steam injection volume, above, periodic gas injection volume, above, steam injection speed, and the design method is according to the geological conditions of the reservoir. Numerical stimulation is used to analyze the influence of steam injection dryness, steam injection volume, and steam injection speed on the half and puff effect of steam injection wells in each period, so as to determine the periodic oil production and average daily oil production cycle, oil gas ratio, and other indicators. Effort should be made to improve the dryness of steam injection, especially the best wearable insulation technology should be adopted. The quality of the insulation pipe string must be guaranteed when going downhole, and the annulus of the oil casing should be drained to ensure that there is no water. The steam injection rate should be appropriate, If it is too low, the variable heat loss will be too large. If it is too high, it may exceed the fracture pressure of the oil layer and open the oil layer, forming cracks, resulting in adverse consequences of the steam channeling in the oil layer, and the amount of periodic injection must be appropriate, preferably 8 to 120 tons per meter of steam injection, and should increase appropriately with the increase of steam injection cycle. Part 4. The measure to enhance the effect of steam half and puff. To grasp the opportunity of timely start up the thermal stimulation recovery for heavy oil reservoir. Here is a question. When we perform steam stimulation for heavy oil reservoir will be better. Let me see the first picture. This is 4 lines. Every line has a different pressure. The first line, the pressure is higher, and the green line, the pressure is lower. We can see the higher pressure maybe have a good result. And the method of replying this question, we need to numeric stimulation. And the example oil field is a China oil field named Kaohsiung. We can see the table. The formation pressure is from 12 to 5. And we can see the pressure is higher, and the total rate is higher, and the peak rate is higher. So the conclusion is under the same production pressure drop, the higher the reservoir pressure is, and the better the effect of half and puff is. And for the thin heavy oil reservoir formation, the oil viscosity about is 500 MPa on the reservoir condition. The daily rate of this kind of oil field obviously is very low, so it is recommended that half and puff stimulation should be performed in the time when the wells puts into production. And 4.2 is gradually increase the injection rate. The law of decreasing oil production of steam stimulation. Initial stage, high fluid rate, high water cut. It is early recovery stage. Also, it is following production period. The daily rate is very high, but water cut is high as well. The water cut is about 80 to 90% within the initial stage during 1 to 3 days, so the daily rate is very low. And the peak production stage, generally the stage is about several 10 days. In the later production days, the water rate is gradually decreased, and the oil rate is gradually increased. and the peak rate comes within from 4 to 5 days. And the decline stage of daily rate. It is about a few months. The rate is gradually decreased because the temperature and pressure of the reservoir are gradually decreased. The viscosity is gradually increased. The daily rate decreases to some extent. The production period will be again into the cold production. That is so sad. Put into the conventional production period. Multi-periodic team stimulation production decline. The oil rate declining. Generally speaking, the peak rate of the first cycle is the maximum rate. Its production period is the longest. Its average daily rate and SOR are higher as well. And the third cycles decrease in turn. The water rate increase in turn. And 4.3, the cause of declining daily rate. The oil saturation near the wellbore decreases in turn with performing stimulation cycles. The large amount of condensate water in oil cycle couldn't be recovered and stored in the reservoir. The water saturation near the wellbore increases. The pressure near the wellbore in the different cycle is decreased. 4.4 some measure. Increasing injection rate. The injection rate shall be gradually increased in every next cycles. Following production. The well should be operated in following production as possible during the couple of foregoing cycles. Once the well is stopped, the following production period should be put into operation in terms of strengthening the artificial lifting to extend the thermal production cycle as far as possible. Reasonably determine the time limit of the daily rate to last the time of the thermal production cycle as far as possible. This table is comparing two different ways of multi-period half-and-half stimulation. The first one, the injection rate is stable. Every cycle is 4,000 tons one cycle. We can see the total oil rate is 22,000, and the total days cycle is 732. And if we increase 15% each cycle, the total injection rate is much more than the first one, and the total oil rate is 24,000. It's better than the first one, and the daily rate is 792. It's better than the first one too. This is the picture comparing two ways of multi-periodic half-and-half stimulation. We can see if we increasing 15% one cycle, the total production is higher than the stable rate y circle. Improving the artificial lifting ability in large production pressure difference. It is benefits increasing the daily oil rate performing half and puff stimulation under the high level of the reservoir pressure. That is to say, only enlarge the pressure drop. Let the bottom hole pressure to be the lowest value. The effect of half and puff will be most ideal, especially the peak daily oil rate will be achieved easily. And preventing the reservoir formation from damage. From the real well test, we know that the oil rate is better when the formation is slightly damaged. The skin is 1 to 5. The oil rate is 55 to 65 tons per day. When the formation is heavily damaged, the skin almost 30, and the peak rate is decreased to 45 tons per day. It shows that the extent damage can affect the oil rate level, but its extent is still not severely compared to the conventional reservoirs. It must be the benefit of the thermal stimulation. Yeah, this picture shows us the skin factor to the daily rate. We can see the formation damage is better, the skin is lower, and the production rate is higher. And determine the perforating pay zone thickness and location. Many oil field practices are shown that reasonably determine the perforating pay zone thickness and location is the most effective method enhancing the vertical steam sweeping efficiency. Someone had studied the effect of this drop to the oil rate with the physical stimulation and the three-dimension, three-phase stimulation method, and had given the conclusion that open the lower half part of the formation thickness not only can benefit the steaming flooding production, but also can benefit the half and puff production. Case 1 is the effect of the perforating extend to the half and puff stimulation recover of the Goshen oil field. We can say if we perforating the whole thickness, the total recovery is 8.54%, and we perforating lower part of half thickness, the total recovery is 11.38, and we perforating the lower part of 1/4 thickness. The total recovery is 10.27. We can say in this case, the second one, perforating the lower part of half thickness is the best one. And the case 2 is to show the Xinjiang oil field. This is the oil field in China and the Xinjiang province. If we perforating the whole lower layer thickness, we can have the total recovery of 14.2, and we perforating the lower part of half thickness, we can have the total recovery of 14.8, and we perforating the lower part of 1/4 thickness, we can have the total recovery of 15.1. In this one, the second and the third case is better than the first one. So we can say if we perforating the lower part of thickness, we can get the better production. And increase the slim quality. Correctly choosing the isolated tubing dimension. We can see the picture. The isolated tubing is better, and the downhole slim quality is good. So the principle of choosing as isolated tubing is that the diameter of the tubing should be as smaller as possible under the condition of ensuring the wellhead pressure being not too high, and ensuring enough steam injection rate in order to reduce the heat loss, enhance the slim quality. Eliminate the heat point. We can see the table. We have some variable metical structure. The tubing like 7-inch like this, and the annual mechanism is different. We have the air, pure water, isolated fluid, and so on. And in the result, we can see the isolated fluid is better than the pure water and air. So we need to use some isolated fluid or some isolated machines to limit the heat point, and in order to decrease the heated losses. To decrease the heated losses, the temperature losses, we can using the heated isolating slivers. This tool is the isolating slivers, and this sleeve can protect the tubing and can reduce the temperature losing, and will make the better result. This one is using a qualified higher temperature heat sensitive packer. Use the isolated tubing and the expansion joint and thermal packer, and can make the steam quality better. So this picture shows us the bigger the casing diameter is, the better the effect of isolating heat is. As the same simulation condition as follows. The casing size is 9.58 inch and 7 inch. We can see the surface steam quality is the same, and the downhole steam quality The bigger one is better than the small one. This one is the conclusion steam quantity for casing size of 958 inch. And this one is completing steam quality for casing size of 7 inch. The results show us the bigger one is better than the 7 inch. Yeah, this is the result. And the last one is replace again tubing in time according to the requirement of standard. We can see if the as routine tubing used several times and have some broken or some corruption, so it's not can have the good isolated. So we can see the table. When we change the new one, it's better than the first one. Yeah, the last one we will talk about the steam gas generator. The steam gas generator we will have another part in the lessons. In this one, we have a general introduce. Injection makes gas for gaining the driving pressure of the formation using the facility like steam gas generator. Steam gas generator has some part. This one is the generator and the compressor and the pump and control device. Okay, that's all of the steam half and puff. Thank you very much. Okay, let's begin another topic of heavy oil thermal recovery engineer. This topic is sand control. We have the 8 part. The first one is harmfulness of producing, and the second one is the principle of sand control. The third one is the method of sand control method. And the fourth one is 3 kinds of mechanic sand control. And the 5 is the design of the gravel packing sand control. And the 6 is the gravel packing sand control method in casing. And 7 is the open hole graving packing sand control method. And the 8 is double layer pre-packed screen. So we can start at the first part, harmfulness of producing. This have a question. Is it inevitable for heavy oil reservoir to produce sand? That's me thinking about this question. So it's almost invariably true. The first one we can see the sand burning the pay. And what's the result? The sand burning the pay? It means the reduction rate of where is dead. And the second one is operation downhole pump. The result is reduction rates of stuck pump. This one has some sand in the pump, so the pump will stuck or the reduction rate is reduced. And the third harmful, let me see the picture. The sand produced from the well and to the tank goes more and more and more, and it will difficulty to operation. And the fourth is appearing cave and collapse. We can see the picture. The sand is produced and the formation have the caves. It will make the casing collapse. So this thing can cause casing deforming and collapsing. The well will dead. Okay, let's begin the second part. The principle of sand control. The principle of sand control is early treatment. Early treatment means performing sand control before a producer starts into the production. The idea was formed after numerous failures of former engineering doing the job, so it's the advanced and correct conception. If it is done too late, not only should we suffer all the above economic loss, but also might it discount the effect of sand control job. In the extreme situation, we can't make the job successfully because of the formation pressure drop. The cause of producing sand. The first one is be congenitally deficient, weakly consolidation, affected by the following factors: less binding material, uneven distribution, the category of the binding material, geologic period, the factor of oil field development, damage, consolidation, fluctuation of the formation pressure, the factor of the production technology, water swelling, clay. You can see the category of producing sand formation. Quicksand type formation, minor cement, and the particular consolidated formation, less cementing material. And the third one is friable sandstone, medial cementing formation. The first picture we can see the producing sand regularly of the quicksand type of formation. And the second picture we can see the producing sand regularly of particular consolidated formation. And the third one shows us the producing sand regularly of friable sandstone. We can see this picture, the identification of the sanding formation. There have two methods. The first one is Mr. Wang show us the delta above 295 and should take the sand controlling measure. And Mr. Dong told us the delta T about 312 is possible producing sand, and the delta T about 345 it's extremely easy to produce in sand. We can see some wells. Example, this well is Emerald's oil field. The CA1, the pay zone is all the M. The delta T is A1 is 334 to 500, and B2 is 295 to 443, and L11 is 228 to 331, and R30 is 328 to 443, and Z9 is 295 and to 344. These five wells all produce the sand. There are some so we can see the third part, how to control the sand, the method of the sand control. Okay, the sand control method have 4 types. We can see one by one. The first type, arc sand control. It have two types. The first one is restricting the producing rate. One is increasing the number of perforations and increasing the diameter of the perforations, and restricting the flow rate. And second one is increasing the variable stress using the expanding packer in the open hole. The second method is mechanical sand control. The stand-alone screen and liners, bare liner. It contains slotted liner and puncture liner. And the bare screens, it contains the screens, wire-wrapped screens, and bound gravel tubing, a tube. The second one is gravel packing, sand control. First one is casing pack, and the second one is open hole pack. The third method is chemical sand control. The first one is resin corsellated. It has double layer pre-packed screen, and the injection method downhole synesthesis method. And the second one is artificial borehole wall. It has resin slurry and cement slurry and coated nut shell. And the last one is short-term in-situ combustion. We can see the red one. We are focused on this mechanic sand control, so we mark the red one. This is the guideline for choosing a sand control method. We can see The heterogeneous reservoir standalone is suitable. Graham Packer is suitable, and resin-coated gravel is suitable, and expanding packer is suitable. The first one is low permeability formation. Just expanding packer is suitable. And multiple zone. The standalone is suitable. Grab packer is suitable. Resin-coated gravel is suitable, and the expanding packer is suitable. And suitable interval. Standalone need short and long, and grab packer is short and long, and resin consolidation is below 3 meter, and resin coated gravel is below 10 meter, and expanding packer is between 6 and 12 meter. No rig. Just resin consolidation is suitable, and high pressure wear. The resin consolidation is suitable, and the expanding packer is suitable. The high production rate wear. The resin consolidation is suitable, and the expanding packer is suitable. Open hole wear. The gravel packer is suitable, and the resin consolidation is suitable. Resin-coated gravel is suitable, and the expanding packer is suitable. And the thermal production wear. The gravel packer is suitable, and the resin-coated gravel is suitable. Sanding seriously. The gravel packer is suitable. The resin consolidation is suitable, and the resin-coated gravel is suitable, and the expanding packer is suitable. The deviated hole. The standalone is suitable, gravel packer is suitable, and the resin consolidation is suitable, resin-coated gravel is suitable, and the expanding packer is suitable. And the deviated hole. The standalone suitable, gravel packer suitable, resin consolidation suitable, resin-coated gravel suitable, and the expanding packer suitable. And oil wear. The standalone suitable, and gravel packer suitable, resin-coated gravel suitable, and the expanding packer suitable. The perforating completion. The standalone suitable, gravel packer suitable, resin consolidation suitable, resin coated gravel suitable, and casing diameter. Standalone conventional, and gravel packer conventional, and resin consolidation small conventional, and resin coated gravel small conventional, and expanding packer small conventional. And downhole junk. Standalone have, gravel packer have, resin consolidation have, and resin coated gravel no have, and expanding packer not have. And expense. The standalone is low, the gravel packer is medium, and the resin consolidation is high, and the resin-coated gravel is between medium and high, and the expanding packer is low. And the success ratio. Standalone is high, gravel packer is high, resin consolidation between low and medium, and resin-coated gravel between medium and high, and expanding packer between medium and high. And the term of validity. The standalone is short, the gravel packer is very long, and the resin consolidation between medium and long, and resin-coated gravel is very long, expanding packer is very long. Illustration. One, the method resin-coated gravel in the above table means screen the resin-coated gravel with pumps into the formation and forming the artificial whereby wall to achieve the aim of sound controlling. 2. According to the table above, it's better that we choose the gravel packing method in our company's oil field, capillary oil field. The second one is in order to understand easily the size of the sand produced from reservoir. Here we give the standard of China, clastic rock granularity analysis method. Yeah, we can see the gravel, the sand size is medium. Medium means between 4,000 to 64,000, and fine means the size between 2,000 and 4,000. And the sand, gained sand, the size means between 1,000 to 2,000, and coarse sand, the size between 500 to 1,000, and medium sand, the size between 250 to 500, and the fine sand, the size between 125 to 250. The very fine sand, the size between 62.5 to 125. The silt sand, the coarse silt sand, size between 31.25 between 62.5. The fine silt sand, size between 3.9 to 31.25. The clean size below the 3.9. Okay, the fourth part. Three kinds of mechanical sand control method. Okay, 4.1 Standalone completion. The principle, install the liner on the screen at the location of the page and control the sand. We can see the first page is the standalone completion. Just have the liner like this, and they have some advantage. It's simple structure and convenient to install. It's easier to install, and it's cheaper. And do this job need a very short time. We can see the second picture, the liner or screen plugged by sand. This is we talk about the disadvantage of this completion. Sand produced easily and production plugging the screen or liner. And we can see the third picture, the liner or screen burned by the sand. Yeah, like this. So the sand burned the liner and produce were reduced and all plug the liner. Okay, the 4.2, the category of the sand control screens. There are 4 sand control liners, like shown in the below picture. The first one is slotted liner. It's the very simple liner. And the second picture is the punch the screen. It's better than the first one. The picture 3 is punched screen jacket, and the picture 4 is base pipe. Sand control screens. The first one is a wire-wrapped screen. Assembled picture of the premier sand screens like this. And the picture 2 is wire-wrapped screen jacket. Picture 3 is appearance. Picture 4 is inner structure for the liner screen. Yeah, 4.3, the mechanism of the grave packing set control. The main and the basic task of the graver, clean, graded sand packed is to form an artificial ridge to restrict the movement of the formation sands, and some fans are always allowed to produce, and that can be beneficial because it helps in cleaning pore space. In such way, gravers guard the whole of the screens to avoid them to plug, and at the same time, the screen should have good self-cleaning property. That is to say, the screen should have simple structure so that it can restrict all the graver grease packs and let the fine sand to produce out of the oil bearing. Yeah, 4.4 casing packing. Conventional casing packing. Compared with the standalone completion, the production rate of the conventional casing packing is higher than the bare completion because of the preventing movement of the sand produced from the oil bearing and avoid plugging the hole of the screens. We can see the picture. The first one is conventional casing packing. We can see we put the gravel in the hole between the casing and the liner. And the second picture is squeezing gravel packing inside casing. Yeah, we inject the gravel to the perforating from the perforating to the formation, and then plug the downhole between the casing and the liner. Yeah, the screen ground packing compared with the conventional completion, the production rate of the screen ground packing is higher than the conventional one because of preventing the sand from the oil buying into the perforating and enhance the permeability of the channel of the flowing fluid. Yeah, we can see if from the perforating, the gravel come into the formation and make some channels and let the oil to fluid easily to the downhole. and pump to the ground. The disadvantage of this packing, gravity packing. The production rate of the two methods is lower than the one of the perforating wear, about 11 to 33%. And the second disadvantage is the thickness of the packing layer is a little bit thin, and this might easily let the sand break into the wear ball. And the scope of the application wear. The method is suitable for the perforating wear. Okay, 4.5. The frac and the pack. Purpose. One very successful application area is the combination of the frac and pack with gravity packing in reservoirs where sand exclusion is needed, but gravity packing alone has been shown in reduced wear productively. And suitable reservoir. Frac pack sand control measure is typically used within relatively higher permeability formations. Generally, such a reservoir produces conventional oil rather than heavy oil, which needs a thermal recovery measure. And frac pack sand control technology. The measure should be performed the fracture stimulation on any scale you need at the breakdown pressure of the pay first, and then do the gravity packing job normally. Yeah, this picture shows the frac pack. How do we do the frac pack? Yeah, we make the frac from the perforate, and then fulfill the gravity in the downhole. By the way, the purpose of screen pack is mainly for sand control, and the mechanism of screen pack is gravity is packing into perforation and the voided space caused by sanding near the wear ball. The pressure grade of screen packer is lower than breakdown pressure, and the suitable wear is heavy oil wear, thermal recovery wear. And the frac pack, the pack purpose is mainly for the improve the production rates. And the mechanism is making the fractures lower down the fluid flowing velocity and achieve the aim of improving the rate and preventing sand to produce. The pressure grade is at the breakdown pressure, and the suitable wear is the wear in conventional high permeability reservoir, which exists in effect of velocity sensitive. The measure indicating velocity sensitive, a critical flow velocity, and the velocity sensitive index is the percentage of permeability reduction above the 10%. 4.6 open hole gravel packer. Yeah, we can see this picture, the diagram of open hole gravel packer. Yeah, we drill the well and make the casing here, and then drill a larger hole in the production formation and hung the liner. Then we put the gravel in the open hole, just like this. This sand control has some advantage. Is compared with the casing packer, the open hole packer method can improve the production rate to 20 to 30%, and the total cost might be equal to the cost of casing one or less a little bit than the casing one. The disadvantage. The cold production rate will decrease because of the filter cake which formed when taking the measure of leak resistance when the reservoir pressure is too low. The process of method is a little bit complex compared with the casing pack. The suitable well. The measure is very suitable for the well with an individual reservoir. Uh, 4.7 Comparing three method control methods. Yeah. Stand alone. The production rate is very low than the perforation well. The cost is very low. And the casing pack, the production rate is lower than the rate of the perforating well, about 11 to 33%, and the cost might be equal to the open hole packing well. And the open hole, the production rate is higher than the rate of the perforating well, about 20 to 30%, and the cost might be equal to the casing pack well. Yeah, sand control well productive of the Lake Maslova oil field. We can see some simulation. For the perforation, they have 20 wells, and open hole they have 14 wells. Screen pack they have 19 wells, and casing pack they have 14 wells. And the PI, the open hole pack, is the best. By the way, squeeze pack means squeeze some gravel grains into the formation around the well bore and the whole of the perforations, and it can raise the productivity of the well. Some author call the screen pack method a high pressure gravel packing method. Okay, the fifth part is the designation of the gravel packing sand control. Yeah. 5.1 is obtain a sample of formation sand. The medial grain diameter is D produced sample is below the core and equal the sidewall core, and the build sample is best. The formation site sample of a core or sidewall core is reliable. B. Suitable distance of obtained samples. We can see the table. The distance is long. As long as the distance, the reliability is lower. So, if we can get the near variable sample, is the best. Uh, 5.2 Run a sieve analysis and plot. This is the sample of capilla A1 where sieve analysis plot, and we can conclude the medial size of the sand. So 5.3 we can select the gravel size. The Socius gravel sand experiment divorce, and the formula of the selected gravel size is Socius given an experiment with above divorce. In this experiment, he obtained the formula used to select the gravel size. D 50% is 5 or 6 D 50. Where the big D 50 is the median size of the gravel truss, and the small D 50 is the median size of the sand produced. The example of the gravel size calculation is we can make the example of CA1 where the big D 50 is 5 to 6 multiply small d 50. So the result is 1.48 to 1.78. And look up the following table and obtain the gravel size 8 to 6 mesh. Also, we can obtain the CR30 where gravel size is 12 to 20 mesh. This is the gravel size and the screen size. We can choose we calculate the result and can choose the screen size like this table. Uh, 7.4 Pick the mass of the produced screen based on the gravel size. Screen size is the minimum size of the gravel size. For CA1 where is 0.68, and for R30 where is 0.74. Mass of the screen can obtain from the above table. So the mass for CA1 is 30, and the mass for CR30 is 24. 5.5 pick the producing screen lengths and diameters. Overlap the entire perforate interval 5 feet, and run screen all the way through the interval and to PBTD minimum the blank area below screen. pick up the screen size based on the driver size. Oh, it's the same. Uh, 7.8. Pick up the screen diameter. For the casing pack, set control wire. Radio clearance between screen and casing should be equal to larger than casing diameter 15. For the open hole pack set control wire, radio clearance between screen and sand face should be equal to or larger than casing diameter 100. We can see screen size for open hole. The casing size is 5.5 inch, and the open hole size is 12. The screen size is 278 inch, and the casing size is 7 inch. The open hole size is 14 to 16, and the screen size is 4 inch, and the casing size is 7.58 to 8.58 inch, and the open hole size is 14 to 18, and the screen size is 5.5, and the casing size is 9.58 inch. Open hole size is 16 to 20. Screen size is 7 inch. The casing size is 7.4 inch. And open hole size is 16 to 20, and screen size is 7 inch. Another table is show us the screen size for casing screen. Casing size is from 8.5 to 10, 3.4 inch, and the screen size is from 2 inch to 5 inch. This one we don't talk about detail. Oh, 5.9 is calculate the annual volume of packing grammar. For the casing packing ware, the volume equals to V screen casing plus V squeezing into formation plus V blank pipe casing and plus V telltale screen casing and plus V supplies. For the open hole packing wares, the volume equals V screen wall plus V blank pipe wall and plus V blank pipe to casing and plus V telltale screen to casing and plus V supplies. This picture will show us casing pack. We can see the picture. And this picture will show the open hole pack. We can see the picture. Yeah. (5.10) Select the type of screen. Yeah, the first one is well wrapped. The self-clean effect is good, and the corrosion resistivity is good, and the thermostability is good, and the premium screen is self-clean effect is poor. The corrosion is good, and the thermostability is good, and the slot liner The self-clean effect is fair, the corrosion is poor, and the smooth stability is poor. And punch liner, the self-clean effect is fair, the corrosion is good, and the smooth stability is fair. Yeah, this is the bigger picture for each one. Comment. The sand green plug, just like this, the complex structure of the two screen jackets. The two layers of premium screen jacket are too complex to discharge the sand produced from the paint effectively. The premium screen has so many layers that the real mass of the screen is larger than the designation value. Then the real length of screen hole are smaller the value of designation. So it has a poor self-clean characteristics, especially where you see it has a standalone screen sand control method. Compared comprehensive characteristics where wrapped is better than the premium screen, is better than the punched liner, and better than the slotted liner. The well-wrapped screen has been widely used in all over the world because of its comprehensive characteristic. There has the possibility of the plugging of the whole of the screen because of the poor self-cleaning of the premium screen, especially in the standalone sand control condition. Punched liner is essentially the same as the slotted liner and has difficult to control the size of the slot and having an additional pressure drop caused by the changing of the following direction. So it is not a good solution, especially for the standalone sand control situation. Slotted liner is made of common carbon steel. They are not be anti-corrosive. There is no thermal stability, so it can't available be used in the thermal recovery situation. 5.11 The conception of the telltale screen and designation. Usage. In order to successfully perform the packing job, there is a screen pipe in the packing tool sample for the telling the staff doing the packing job, the downhole situation. Classification. Up-telltale screen. It is located on the top of the producing screen. We are using lower density slurry. Lower telltale screen. It is located on the bottom of the production screen. We are using lower density. Principle of upper screen. When the gravel greens are paired up to the top of the production screen, there has a relatively steady pump pressure at the surface. When the space between the blank pipe and casing is fulfilled with gravel, the surface pressure started to rise and the pressure is raised quickly. When the tilting screen is complete burned, the pressure is sharply increased and packing is completely over, and the packing job is stopped. The low screen. The effect of it is to give a channel at the bottom of the packing screen and let the high density slurry to flow into the lower tier screen. Force it not to flow into the production screen completely. Avoid the gravel to pile up at the production screen. When the slurry is reached down to the tier screen, the pump pressure at the surface is obviously raised. The packing job can be turned into the next step, the screening status. Size and length of the screen. The diameter is the same as the production screen, at the length is generally about 1 or 2 meters. This picture is showing the job process of the packing gravel with the upper tier screen. You can see the picture. The sand is fulfilled, the bottom sand is upper, the pressure is upper, high. The sand is burned the ladder. The pressure is very big. Okay, this is the job process of packing gravel with the upper tier screen. Uh, 12.12 The design of the blank pipe. Diameter equals to the diameter of the base pipe of the well-wrapped screen. The length circulating pack minimum length is 90 feet. The screen pack no circulation. 10 pps slurry blank length is 5 production screen length. 15 pps slurry blank length is 4 production screen length. The wear deviation from 0 to 45 is 15 feet, and from 55 to 60 is 15 feet, and above the 60 is 5 feet. Yeah. 5.14. We need to choose the gravel pack methods. The first one is washed downhole, and the second one is reservoir circulation, and the third one is crossover. So there are 3 kinds of basic methods which can be available for the packing job. The tool of the wash-down gravel packer. The principle. The gravel is previously filled into the bottom of the hole in the well, which were packed first, and then use the washing tool to flush the gravel and force them thrown up and distribute and mixed uniformly with the fluid in the downhole. Running hole the packing stream with the screen slowly, and the gravel grains fall and pipe around the screen. In order to achieve the favorable effect of the packing gravel, we can screen some amounts of the gravel into the hole of the perforation first. Features. The tool and the technology are simple to operate, but easy cause the phenomenon of the gravel separation by the force of the weight. The rim, shallow well, the thin zone. The wash-down gravel packer technology. We can see fill gravel first and run in hole wash tool and wash down, waiting for the settlement and completion. Reservoir circulation of the gravel pack. The process of the technology means that the slurry with the gravel is pumped into the annual and leave the gravel around the screen, and the working fluid flow out of the surface through the tubing. When we shut the tubing valve, the gravel can be squeezed into the formation and the hole of the perforations. The features of the technology. It is relatively simple, but there are some disadvantages. Polluting the gravel grains can decrease the permeability of the layer grain. The casing should withstand relatively high pressure, and the amount of the working fluid is relatively large. So the method should be a good solution for packing gravel job. Crossover circulation of the gravel pack. There are some kind of crossover circulation tools to perform such packing technology. In this case, we give the example of the 4 times crossover circulation packing gravel method as follows. Then the first one is pack the down part. Second is screens pack. And the third one is pack the upper part. And the fourth one is reverse verse tubing screen. So the slurry can be classified to 4 kinds according to the viscosity of it. Low viscosity is 50 to 100, and high viscosity from 500 to 700. Medium viscosity from 300 to 400. The slurry pump rate can calculate like this. So 5.6, the driver pack producer guideline, perforating. Nowadays, there has a tendency that people use the high density and big diameter of the perforations, 36 to 60 holes per meter, and scraping, casing, perforating, cleaning, and running hole the packing string, then reserve wash down before packing, and then pre-packing the cavity near the wear ball and the perforations with the gravel. Then the reverse washing job and running hole the production packer and start to production. The sixth part is casing pack technology. See part 1. The parameters and the comment of the 2 kinds of packing method. We first see the conventional packing. The viscosity need to below 30, and the ratio of gravel to fluid from 5 to 10 and to 100. The pumping rate from 400 to 500, and the pumping pressure P plus 4 to 5, and the tire position upper. The packing type, open hole packing and casing packing. Slurry amount, working time is much slurry, time is longer. Gravel broken amount is much. The permeability change time of the perforations is lower. The settlement situation of gravel pack is less. In high density packing, the viscosity is from 300 to 400, and the ratio of gravel to fluid from 8 to 100 and to 100. Pumping rate from 250 to 300. Pumping pressure is P plus 7 to 10. Tire position is lower, and the packing type is open hole packing, casing packing, perforation screens, and the slurry amount and working time is less slurry, time is shorter. Gravel broken amount is less. The permeability change time of the perforation is higher. The settlement situation of the gravel packer is much. The note: in the above table, a P equals to the pump pressure of the circulation and washing the stream before packing. The pumping pressure in the table should be less than the breakdown pressure of the reservoir. 6.2. 2 kinds of screening pack method. There are two kinds of screening packer methods, one-step method and two-step one. They are all belongs to the high-density packing method. Two packing method technology, preparing the borehole and pre-packing the perforations and the cavity space, running-hole the bare tubing stream into the depths. The top of the reservoir measures about 10 meters. Pumping the high-density slurry into the tubing. Close the casing valve. Force the slurry to pack into the perforations and the formation near the well bore. Choose the well and wait for the pressure diffusion. Squeeze again according to the practical necessity. Make TOC and cleanse. Pull out of the stream. Run-in-hole the packing stream, like with well wrap screen or others. This method is usually used on the old well, which will do the final packing job. And run-in-hole the packing stream, like well wrap screen or others. One-step packing technology. Preparing the borehole, run-in-hole the packing stream, like well-wrapped screen or others. Setting the packer and start a normal circulation. Screen pack. Pump the high-density slurry into the tubing. There are spacer fluids before and after packing job. When the slurry arrived at the screen, choose or control the casing valve and adjust the pumping rate. Squeeze the gravel into the holes and the formation. Stop to pump the slurry and close the well valve until the pressure has reached the value of designation. Again, squeeze the gravel after the pressure diffusion until the well can't absorb the gravel. This method is usually used on the newly drilling well, which will do the initial packing job. Graving packing on the thermal production well. The main difference points comparing with the cold production well packing method are as follows. Use the lead seal thermal packer. The packer is used as sealing the annual space between the casing and the screen to prevent the gravel from overflowing out during the period of the steam. Injection and production, and ensure the effect of the sand control for a long time. This tool is a mechanical lead back-off packer. And the second one is hydraulic lead back-off packer. Use the thermal-suitable screens. The structure of the thermal screens, see the diagram. The technical feature. The bottom end of the screen jacket should be fixed on the base pipe with pins screwed, and the top end of the screen should be in freely moving in order to prevent it from expounding damage in the process of the steam stimulation. The sealing performance of the two end of the screen should be reliable, and the diameter of the through holes on the base pipe should be as larger as possible. The screens should be made of a non-corroding metal, and the category of the graver should satisfy of the required of anti-alkali resistant properties. This picture is show us the thermo-suitable screen assemble. 1 is the upper box, and 2 is central tube, 3 is upper gland, 4 is seal staff, and 5 is screen jacket, 6 pin, and 7 is seal staff, and 8 is lower gland. The 7th part is open hole graver pattern. Features. Advantage. The pressure drop is less, and reducing the movement of the number of the fans because of the area of video's region become larger, so the productivity is improved. Reaming borehole makes the packing layer more thick, leads the sand control more effectiveness. Disadvantages. The procedure is a little bit complex. The filter cake forming from lost circulation material might affect the productivity of the wear. The special technology for open hole wear packing. Reaming the borehole. The diameter of the borehole in the pay zone should be larger than the upper part of the diameter of the wear bone, about 3 to 5 reaming fluid. A lot of reaming fluid invasion into the formation might easily cause the damage of the pay. So our duty is to control the fluid leaking into the formation during doing sand control job. Screen assemble. The diameter of the screen. It should ensure the graver layer thickness about 75 to 100. The minimum thickness is 50. This table shows us the recommendation size of the screen in the open hole wear. We can see the casing size is 5.5 inch, open hole diameter is 12, and the screen size is 2.78 inch, and the casing size is 7 inch. The open hole diameter is 14 to 16 inch, and the screen size is 4 inch. And the casing size from 7.58 to 8.58 inch. The open hole diameter is 14 to 18, and the screen size is 5.5 inch. The casing size is 958 inch. The open hole diameter is 16 to 20. The screen size is 7 inch. The casing size is 10.34 inch. The open hole diameter is 16 to 20, and the screen size is 7 inch. The length of the screen. The production screen length should be ensured to overlap the pay thickness, exceeding the top and the bottom about 1 to 2 meters. The telltale screen should be within length about 1 to 2 meters. 7.4. The black pipe size. The length in the reaming interval. Reaming interval below 3 meters is 3. The reaming interval above 30 meters. The reaming interval to 10. The black pipe length overlaps the casing is from 20 to 30 meters. Here is a case of Brazil oil field. The oil field is called pre-Brino. It is an offshore field. The depth is 2,500 meters. It is the horizontal interval length. The horizontal interval length is from 1,450 to 5,000 meters. The sand control method is open hole grab packer, and the screen model is a rear wrapped screen petrol guard 5.5 inch. Yeah, this is standard production wear completion. They use the Halliburton rear wrapped screen. This screen, you can see the one is central pipe, and 2 is rear wrapped screen jacket, and 3 is centralizer. We can see another case. This is a China offshore case. The oil field is Jordan offshore field. Location is in China, Bohai. The horizontal interval length is from 300 to 400 meters. And the sand control method is open hole grab packer. And the screen method is a premium screen. The oil viscosity is from 1.6 to 30.6. This one is they use the premium screen. The first, the one is base pipe, and the 2 is a wire wrapped pad, and the 3 is a premium screen jacket, and 4 is a punched protect case. We can see the oil field sand control table complete. About the screen pack, have the 754 wears and successed 745. The success rate is 98.8%, and its valid days is 1,128. The well-ranked have 659 wells. Success the 629 wells. Success rate is 95.4, and the valid days is 1,596. Racing quoted have 285 jobs and success 230. Success rate is 80.7%, and the valid days is 395. Chemical control have 63 jobs, success 40, and the success rate is 63.5, and the valid days is 260. Scent control waterproof have 32 jobs, success 20. Success rate is 62.5, and the valid days is 275. The eighth part is double layered pre-packed screen. The 8.1 technology loads the resin pre-coated gravel into the space between inner and outer screens, consolidate it at a certain temperature, and form the screen. The range suitable for commingled pay-zone. Suitable for wear which can't perform the casing gravel pack because of the casing inner diameter is too small. The dimension. The inner and outer screen jacket should have the same mass. The mesh should be equal to half a diameter of the pre-coated gravel, and the clearance between the outer screen jacket and the casing should be as small as possible. The clearance should keep about 10 for ensure the long term of validity. The thickness of the gravel layer should be about from 15 to 25. Okay, that's all about the scent control topic. Okay, let's begin the last topic of heavy oil thermal recovery engineering. This topic is mobile steam injection station. We have six parts. The first is the basic conception of steam station. And the second one is the mobile steam injection station. The third one is steam generator. Fourth one is water treatment. And the fifth one is steam generator anti-corrosion and anti-scare. And the last one is intelligent control. So we began as the first part, the basic conception of steam. Here is a question. The higher the steam temperature is, the more steam heat quantity is. Is the truth? Sometimes true, and sometimes not. Why? The relationship of the saturate temperature and pressure. Saturation state, the heat water. When water is evaporated into steam, equals V steam is condensated into water. We call the system as beginning the saturation state. Saturated steam, saturation water, saturation pressure, saturation temperature. We respectively call the water, the steam, and its pressure, temperature as the saturated water, saturation steam, saturation pressure, saturation temperature, where it is at the saturation state. Superheated steam. When the saturated steam is continuously heated, the last drop of water is turned into vapor, and the temperature well exceeds the saturation temperature. In this situation, we call the steam as superheated steam or dry steam as well. Critical point and supercritical steam. The state with the maximum saturated pressure and the maximum saturated temperature is called critical state, and the corresponding point to the state in the Descartes coordinators is called critical point. When the pressure and temperature exceed the values of the critical point, the steam is called as supercritical steam. In the supercritical steam system, the two phases have the special property, that is to say, they have the same density and enthalpy, and the higher the temperature is, the more amount of enthalpy the steam has. It is different from saturated steam. The amount of the enthalpy of the supercritical steam increases with increasing of its temperature, decreases with decreasing of its temperature. The relationship between pressure and temperature in the saturated steam system is the following one, where Ts is saturated steam temperature and Ps is saturated pressure. The relationship between the saturated pressure and temperature, we can see the picture. The water region, the temperature is lower, and the water region is and the fluid is water. And we can see the red line is saturated line. And the temperature in the red line is called critical temperature. When the temperature or the pressure above the red line, we can see the superheated steam region. So what kind of physics behavior is at the point of pressure, 10 MPa? We can say the pressure is 10 MPa, the temperature is 300, 310, and 320. The region is water, saturated steam, and superheated steam. The steam quantity is when the temperature is 300, the steam quantity is 0, and the temperature is 310, the steam quantity is from 0 to 100%, and the temperature is 320, the steam quantity is 100%. The phase behavior, the first one is only water, and the second one is water and steam, and the third one is steam only. The second part, the quick steam injection station. This is consists of the steam injection station. The first one is water tank, and the second one is steam generator. Third one is failure tank. Fourth one is water treatment device, and the blow down device. And the last one is the inject well. The main parameters of the mobile steam injection station. The first one is the maximum capacity of water treatment. This value is 13. And the second one is the maximum capacity of steam injection. The value is 11. And the third one is maximum pressure. Value is 70. 4 is maximum steam quality. Value is 80%. 5 is fuel oil consumption. The value is 65. And the last one is area required. The value is 30 multiply 45. The third part is steam generator. The 3.1, the relationship between the steam generator category and the kind of the heater carrier. There have 4 kinds of steam generator. The first one is hot water boiler. They produce the water and the quantity of steam is 0. The temperature for a certain pressure is multiplied temperature. The sum of calories is temperature. The second one is subcritical steam generator. It produces the saturated steam. The quality is from 0 to 100%. And the only one value of temperature existed. The sum of calories is steam quality. The wellhead pressure is lower than the critical pressure. The third one is high quality steam generation. Another called is superheated steam generation. They produce the superheated steam. The steam quality is 100%, and temperature is multiple temperature. The sum of calories is temperature. The wellhead pressure is lower than the critical pressure. The last one is supercritical steam generator. This one products the supercritical steam, and the sum of calories is temperature. The wellhead pressure is higher than the critical pressure. The 3.2 is the category of steam generator. The first one is subcritical steam generator. The pressure of a subcritical steam generator is less than 22 MPa. We can see the consist of this generator. The first one is convection section, and 2 is radiation section, and 3 is burner, 4 is pump, 5 is PLC touch control panel. We can see the typical model. This one, the maximum steam temperature from 312 to 370, and the steam quality is the same. It's 80%. We can see the main feature of this generator. Pressure rate of the steam generator normally is from 10.2 to 21 MPa, and the steam production rate is from 5 to 100 tons per hour, and temperature is the ionic function of the pressure. The sum of calories is the steam quality. The second one is a supercritical steam generator. Definition: the supercritical generator pressure range is from 22 to 27, and the ultra-supercritical generator range is above 27 MPa. And the consist of this generator. The part 7 is a part of the water treatment device, and the part 8 might be as a part of the generator, or sometimes as an independent component. And the 1, 2, 3, 4, 5 is the same as the previous one. The main feature: the rated pressure is from 26 to 35 MPa, and the rated temperature is from 390 to 400, and the steam rate is 7 and 9 and 13.5 tons per hour. Temperature is a multiple function of the pressure. The sum of calories is the same temperature. Water treatment, disk filtration plus ultrafiltration, and plus reservoir osmosis membrane. 7 is as the steam separator, and 8 is as the superheated section. And the third one is superheated steam injection generator. The pressure not exceed 22 MPa, and the temperature can be higher than the corresponding saturated temperature. The steam quantity can reach 100%. This one is the consistency maybe the same as the first one, and the rated temperature is from 360 to 375, and the steam production rate is from 9.2 to 18 ton per hour. Here is some of the steam injection generators. The first one is vacuum-mounted generator, and the second one is high-quality steam generator. Third one is a generator used in Colombia, and the fourth one is a generator produced for South America. 3.3 The main structure of steam generator. First one is radiation section. The structure of radiation section. It has a horizontal cyclical structure. The size of tube of the generator is 73 multiply 11. The steel material is 20 G, arranged along the inside of the cylinder. There are the manhole cover and fire windows at the back end of the radiation section. The function of the section. It is the main heating section of the steam generator. The tubes in the combustion chamber is directly heated by the flame radiation heat. Then the heat is transmitted to the water. Eventually, it is vaporized into steam. The 60% of the produced heat amount of the generator comes from the section. The average temperature of the furnace cavity is normally 950. The flame in the flame cannot directly contact with the tube of the generator. Otherwise, it is prone to occur the pipe explosion accident because of the maximum heated amount gathering. 3.4 is convection section. The structure of the convection section. There are two kinds of furnace tube, bare tube and fin tube. All the size and material of tube are same as the first one. The doors installed at the two sides are the type of rotor shaft. The function of the convection section. The convection section is the auxiliary heating surface of the steam injection generator. It is installed at the tail of the generator and uses the waste heat of the flue gas heating water. Achievement the aim of the saving the fuel, so we call it as economizer. The 40% of the producing heat amount of the generator comes from the section. Yeah, this picture is the section. Oh no. 3.5 The water heat exchanger. The structure of the water heat exchanger. The water heat exchanger is located at the top of a radiation section like the figure. The high temperature of water from the convection section is pumped into the inner tube of the exchanger. The water out of the exchange is pumped into the outer tube of the exchanger. The direction of the two flowing water is opposite. It benefits from the heat exchanger effect. The material of the heat exchanger is 20G. This picture will show the heater exchanger. The outlet temperature of the exchanger should be higher than the temperature of the dew point. If not, the convection section will be corrosion because of the exciting of SO2. (3.5) Burner model. The model of the burner is North American. It can use dual fuels, oil and gas. Performance parameters is blower motor power is 30 kW. The rated producing heat amount of the burner is 30 mmBTU per hour, and the burner warranty period is 5 years. This one is the burner. (3.6) is the transition section. The transition section is located between the convection and the radiation section. The function it has a half-round shape structure, and it is the channel of the flue gas. The maintainers can enter in it and perform their maintenance job. The 3.8 is air compressor. This one is Modulo UG200 to 300. The function is supply air pressure for burner and for all the pneumatic instruments and apparatus pneumatic value and mechanism. Air rate is 2.3 and the working pressure is 0.8 and the motor power is 15 kW. Uh, 3.9 is the main process of steam generator. Fuel heater, fuel tank, fuel pump room, and screw pump, gearbox. Yeah, we can see the steam water system, the raw water, and the through shock absorb and to the pump to through shock absorb and relief value to two-way. One way is directly pump into convection, heated to 318 and into the inner tube of the heat exchanger. Another way is to the outer tube of the exchanger and to heated exchange because of the difference between the inner and outer tube. The temperature of the outer tube water increased to 116 to 118 and then into the convection as well. Then the temperature of the inner tube water decreased to about 274. This picture will show us how the steam water system works. Okay, the fourth part is water treatment equipment. This picture shows us the water treatment plant. And 4.2 is water treatment plant parameters. The dimension is the value is 11 multiplied 3.25 and 3.1. The water producing rate is 13, and the outlet water hardness is 0, and the raw water hardness is below 300, and the pressure is 0.6. The temperature is from 5 to 50. And the resin model is strong acidic cation exchange resin of the model. The principle of the water treatment. If one solid material can combine with some kind of ions in water and can release some amount of other ions, this process is called ion exchanger process, and this material is called ion exchanger agent. The selectivity of the strong acid ion exchange resin model and amount is like this, and the selectivity is like this. Ion exchanger and regenerator operation. The exchanger process is raw water flows through the resin layer at a certain rate. In this process, calcium and magnesium ions in the raw water will exchange with sodium ions in the resin. Then the water quality can meet the requirements of the steam generator. The time between two processes of the regeneration generally about 30 hours. Minimum hours generally 24 hours. And the influence factors is the loading height of the resin, the exchanger velocity, and so on. Backwashing process. It is necessary to backwash a resin layer so that regeneration can be made when the function of the resin has failure in the exchange. The aim of the backwash: lose a layer of exchange agent, slug clean, remove air bubbles. Influence factors: the backwash intensity to make the heat of the resin loses and let it increase from 50 to 60% of the original heat. The backwash time is generally about 20 minutes. The process of the regeneration: the field resin contacts with the appropriate concentration regeneration agent solution at a certain way, then make it recovers the capability of the exchange. Influence factors: type of the regeneration, pureness, the amount of the regeneration, the velocity and the time of regeneration, the way of regeneration. The better way is countercurrent circulation model, and the replacement process lets the regeneration liquid completely through the filled resin layer with fresh water to make full use of the exchange agent. Replacement of water: don't be use the raw water, must use softened water. Conventional washing process: clean out the residual regeneration material and other impurities. The 4.4 is the water treatment process. The picture is this process. The fifth part is steam generator anti-corrosion and scaling. Anti-scale. Scale type is carbonate scale. The carbonate content above 50%, and the sulfate scale. The sulfate content is above 50%, and the silicate scale. Silicate content above 20%, and the mixed scale. Scale with oil. The harm of scale is damage the boiler, wasted a lot of fuel, and reducing the heating efficiency of the generator, and increase the operation cost. Descaling method: pickling, descaling, dissolved stripping, and alkali cleaning, descaling, dissolved silicate and other scale. Clean agent: hydrochloric acid and hydrofluoric acid, corrosion inhibitor, and other acid. This is deoxidization method. Thermal deoxidization method. Temperature of water should heat it to over 52, and chemical deoxidization method is like this, and the amount of the anhydrous sodium sulfate is like this. The price of the sodium sulfate is 2,800 RMB per ton. Prevention acid alkali corrosion. The relationship between the speed and pH of corrosion is like the picture in the right. The case of the pH value of water is in the below table. The method of adjusting pH generally add NaOH. The sixth part is intelligent control. And this is automation equipment. The first one is the PLC and power converter and control cabinet. The features of intelligent PLC control system. The principle of the automatic continuously measurement of the steam quantity. At the same time, the steam can measure the inlet mass rate, the outlet steam volume, flow rate, and the pressure of the steam generator, and the density of the water and steam at a different pressure can be consulted from the relative table. So there is only an unknown variable, the steam quantity X. The job of measuring and calculating these parameters are performed by the system of PLC, computer and pressure gauge, and so on. When the steam quantity is calculated, the steam can automatically control the furnace combustion system, ensure the steam injection job well. The function of intelligent PLC control system. Automatically start up and shut down the ignition system. Automatically control the pressure of the fuel and atomization. Automatically measurement steam quantity and regulating the ignition system. Automatical analysis of fuel gas and regulating the ignition system. Automatic alarming when occurring something, and automatic control ratio between air and fuel, and so on. The alarming system, a core component of the controlling system PLC, monitoring point device, the main parts and the pump, steam outlet, the system of supplying fuel, burner, wall of the furnace, exhaust exhaust, flue gas system, and water supplying system, electrical power system, the parameters measured, monitoring all kinds of temperature, pressure, flow rate, the lubricating situation, and the fault of the fail-out to prevent the generator from serious accidents and ensure the system normally operation. The monitoring point is 20, and the point shut down the generator is 90, and the action, sound, and light. Yeah, this one is the monitoring paragraph and the alarming type. This is the same. It's the same. Oh no. So in the last, we have two questions need you to do. The case one is selecting the burner. The known parameter is maximum quality is 80%, and the maximum steam injection rate is 11, and then the maximum efficiency is 88%, and the maximum combustion efficiency is 98%, and the raw water insufficient is 60. I will give you some minutes to calculate this question. Okay. Do you finish this question? Let's see the answer. Yeah, this is the answer. Do you do the right answer? Let's see the next question. The fuel consumption and the no parameters is maximum quality is 80% and the injection rate is 11 and the maximum efficiency of steam generator is 88% and the maximum combustion efficiency is 98 and the raw water SV is 60. The SV of the steam system under the condition of the maximum steam quality and the pressure is 5 MPa. Injection time is 10 days. And the fuel value is 41,000. Yeah, this is the answer. 180 tons. Okay, that's all for this. Thank you very much. See you.